Hello and hi everyone, my name is Shahmel Irfan. Today, me and my friend Nukman will be presenting one of the most interesting topics in physics, which is projectile motion. Projectile motion is the motion of an object that is thrown into the air and moved under influence of gravity. Well, in real life, air resistance also plays a role, but for simplicity, we usually ignore it in physics problems. When an object is projected, it follows a curved path called a parabola. Well, examples are everywhere, like kicking a ball, throwing a basketball, shooting an arrow, or even tossing a paper airplane. Now, how do we study this motion? We can split it into two components, which is the vertical motion and also the horizontal motion. By combining these two, we can describe the projectile motion.
Thank you, Irfan. Now that we understand the basics, let's explore application and misconceptions about projectile motion. Projectile motion is not just a theory from textbooks. It's all around us. For example, in sports, every basketball shot, football kick, or even volleyball spikes follows projectile motion. In engineering, it's used to design water fountain, fireworks, or even calculate missile trajectories. In entertainment, video games use the same equation to make throwing, jumping, or shooting look more realistic. So now, let's understand a few common misconceptions about projectile motion. Many people think that an object goes up and then stops before it falling.
Dad, begonan anyo.
Gravity acts constantly. At the start, the vertical velocity is upwards and gravity slows it down until it reaches the peak, or we call it maximum height, where the vertical velocity is 0. And then, gravity accelerates it downward again. Another misconception is that the horizontal motion somehow affects the vertical motion. In fact, they are independent. The horizontal motion stays constant, while the vertical motion is always influenced by the gravity.
Right, now let's take a look at some equations and also formulas related to the projectile motion. First, bila kita dapat soalan yang bagi tahu kita the angle or theta and also the initial velocity ataupun u, kita kena always break the u or resolve the u components into the x and also y components. For the x components, the equation is u equal to u cos theta, and while for the uy component, the equation is uy equal to u sin theta. Alright, next, we can actually find the speed at a certain or particular time. So, in horizontal direction, there's actually no force acting on it. That means the horizontal velocity always stays the same. So, we will write it as Vx is equal to ux or u cos theta. But in vertical direction, gravity acts on the object, and this makes the vertical velocity decrease with time. So the equation is Vy equal to uy minus gt, or u sin theta minus gt. Alright, now kita akan tengok kepada maximum height formula or equation. So remember this equation, Vy square equal to uy square minus 2gsy. So bila kita rearrange balik, kita nak cari kita punya maximum height, which is the sy, and then kita akan jadikan dia sy equal to uy square minus vy square over 2g. But remember, at maximum height ataupun at peak, vy is always equal to 0 or 0 meter per second. So in our equation, sy is our h max, g is always 9.81 meter per second. So bila kita substitutekan ke dalam equation yang first tadi, kita akan dapat h max equal to uy square over 2g, or u sin theta power of 2 over 2g. So this is the equation to find the maximum height. Alright, now kita akan tengok kepada our displacement equations. So for displacement equations, kita akan ada dua, iaitu which is horizontal position and also the vertical position. So the first one, the horizontal position, the equation is Sx equal to ux times t, or u cos theta times t. And for the vertical position, the equation is y equal to uy times t minus half gt squared. Alright, after that, we also have the equation to find the range. So for range, the equation is r equal to u square sine 2 theta over g. Alright, lastly, we have the equation to find the time of flight. So the equation to find the time of flight is t equal to 2uy over g, or kita boleh guna 2u sin theta over g. And then after this, you are going to take a look on some problems and also few cases related to the projectile motion.
So dekat sini kita akan ada 2 cases regarding projectile motion. So let's start with case 1. The question states that an arrow is fired at a speed of 45 meter per second at an angle of 30 degree above the horizontal. So we need to calculate its maximum height, how long it takes to reach the maximum height, and then how long does it take to return to the same horizontal level as it started at, and the distance travelled horizontally to the point of return. So benda pertama sekali yang kita kena buat bila kita dapat soalan ialah kita cari apa maklumat yang kita boleh dapat daripada soalan ni. So soalan bagi kita 45 meter per second, which is the initial velocity u, and then 30 degree, which is the theta. And untuk to make it easy for us, kita split the u into 2 components, which is ux and uy. So ux kita ada 45 cos 30 equal to 38.97, and uy 45 sin 30 equal to 22.5. So baru kita tengok soalan dia, dan soalan suruh kita cari maximum height. Seperti mana yang kita tengok dekat formula tadi, h max equal to uy square per 2g, and u sin theta kita dah dapat dah tadi, kita dah cari. So kita buat value untuk uy is 22.5 square over 2 times g equal to 9.81. So kita tekan kalkulator dan kita akan dapat jawapan dia 25.8 meter. So seterusnya soalan dia, how long it takes to reach the maximum height. So kita kena tahu bila mana sesuatu objek tu berada dekat maximum height. So Vy dia equal to 0, final velocity is 0. So Uy tadi kita dah dapat 22.5 minus G equal to 9.81, dan ialah kita cari T yang kita kena nak cari. So kita pindah-pindahkan, tekan kalkulator, dan kita akan dapat T equal to 2.29 second. Seterusnya, how long does it take to return to the same horizontal level as it started at? So kat sini kita ada 2 cara untuk cari jawapan. First kita pakai formula ni, ataupun kita buat dulu formula ni is 2 times 22.5 over 9.81. Ataupun kita pakai formula kita just darabkan 2.29 tu dengan 2 sebab untuk memudahkan kita faham. So bila arrow tu nak sampai ke sini, dia ambil masa 2.29 second, dan bila dia nak turun, dia akan ambil masa lagi 2.29 second. So sebab tu kita dapat 2. So either way kita akan dapat jawapan yang sama, is 4.58 second. And untuk last question, final question of case 1, kita perlu cari distance travelled horizontally, which is horizontal displacement. So ux kita dapat tadi is kita dah cari awal-awal tadi 38.97 dapat dengan t. So kat sini kita akan pakai t yang total sebab kita kena cari distance travelled kat sini. So kita pakai 4.58. So tekan kalkulator dan kita akan dapat jawapan dia 178.48 meter. So selesai untuk case 1, dan saya akan pass kepada Irfan untuk buat beberapa lagi jenis soalan dalam case tu.
Alright, thank you Nukman. So sekarang kita akan tengok pada case number 2, which is an object thrown from a certain height with a velocity u at angle theta above the horizontal line. So the question is, an object is thrown at an angle of 37 degree with the horizontal from a bridge 20 meter above a river. The initial speed of the object is 30 meter per second. Calculate A, the time of flight. So A, time of flight. So actually the case is, objek tu just dibaling di atas jambatan yang berketinggian 20 meter. Maksudnya dia bukan dibaling from the ground. So kalau dia dah bagi u initial velocity and a degree, apa first thing kita kena buat? Kita kena resolve. So our x component is 23.96 meter per second and our y component is 18.05 second. So how do we find the time of flight? Kita akan masukkan je, substitutekan je kepada equation yang kita dah pernah belajar sebelum ni, which is sy equal to uyt minus half gt square. So bila kita masuk kan, kita akan dapat sy kita tadi negative 20 equal to uy kita ialah 18.05 t minus half g is always equal to 9.81 times t square. Bila kita arrangekan dia balik, kita akan dapat satu quadratic equation which is 4.905 t square minus 18.05 t minus 20 equal to 0. So kita gunakan apa-apa cara untuk solvekan this quadratic equation, and lastly kita akan dapat t is equal to 4.57 second. So this is the answer for T. Now kita tengok kepada B. B dia nak cari horizontal range, and this is the formula for horizontal range. So kita just substitutekan je lah. Ux tadi kita jumpa kat sebelah. Our Ux is 23.96 meter per second, and then timeskan dengan T tadi pun kita dah jumpa kat soalan A, which is 4.57 second. 4.57 second. Potong. Lastly kita kena is equal to 109.5 meter. So this is the answer for B. Now kita akan tengok kepada the final question, which is C. C dia nak cari final velocity at impact, and when we want to find the final velocity, kita kena always cari Vx and Vy component dia. So the Vx is always equal to Ux, and our Ux is always equal to, kita dah cari kat atas tadi, which is 23.96 meter per second. Macam mana cari Vy pula? Vy pula kita gantikan dalam equation yang kita dah belajar, which is Uy minus Gt. So substitutekan Uy kita cari kat atas tadi kan, which is 18.05 minus 9.81, T is 4.57. So kita akan dapat Vy is equal to negative 26.78 meter per second. Kenapa negative? Because it's velocity, so dia ada direction, maksudnya direction dia ke bawah. So kita akan cari V final. V final is, this is the formula, Vx square plus Vyx square, kita square root kan, and then also the direction. So kita akan buat yang ni 23.96 square plus negative 26.78 square, and then kita akan square root kan dia. So our V final bila kita tekan ataupun press our calculator, kita akan dapat 35.93 meter per second. Alright, and then for direction kita buat tan inverse. Alright, and then Vy kita negative 26.78 over Vx 23.96. So our theta is equal to 48.18 degree, and then below the positive x axis. Right, so this is the answer for theta.